Dear friends, I myself, Dr. Bharat Parab, discussing the topic algebraic expressions and identities. In this, let us see what is algebraic expression. Let us consider some examples. 2x plus 3, 5y, xy, or in general, ax plus b are all called as algebraic expressions, where x, y, these are the variables and a and b are the constants. Okay, so such examples or expressions are called algebraic expressions. To study this, let us see some definitions of factors, terms, coefficients, monomial, binomial, trinomial, polynomial, like and unlike terms, and addition subtraction rules. These will be very useful to study the algebraic expressions and identities in details. So let us see the definitions of factors, terms, and coefficients, monomials, binomials, trinomial, polynomial, like and unlike terms, and addition subtraction rules. Okay. To understand this, let us consider an example 2x plus 7. Okay. Now, what are factors? See here, factors. These two, x and 7, all are called as factors of the expression. Okay, all individual. There are three. Okay, so these are called factors of expression. So you know what are factors. Terms. Consider the same example 2x plus 7. So here 2x, earlier it was 2 and x and 7. Now here 2x is one term, that is it's separated by the sign and the plus or minus, not into or division. So 2x and 7 are the terms of expression. So can you find the difference between factors and terms? That is very easy. Okay. Terms may contain many factors. So this may have another x, y, z. So these are all different factors but only one term. Okay. And third one is coefficient. In this section, third one, the numerical factor of a term is called as coefficient. This is a term. Okay, so see these examples, terms and coefficient. Term is 5x, coefficient, this numerical factor is 5, that is coefficient. 2xy, so coefficient is 2. Minus 4z, coefficient is minus 4. And for this a, if this a is unknown, then besides this is 1, so coefficient is 1. Okay, so these are the definitions of factors, terms, and coefficient. Try to understand it and you can use it in the problems. Okay, another set of definitions: monomial, binomial, trinomial, polynomial, and names are very suggestive. Monomial means contains one term, minus 4x, 5y, ar square, or minus 10, all are monomials. Binomial. Binomial contains two terms, 2x plus 3, 5z square minus c, a plus 7 are all binomials. Trinomial. Naturally three terms, a plus b minus c or a plus b plus c, 5x plus 9y plus 3z all are trinomials. Now polynomials. See the definition of polynomial. Expression with one or more terms with non-zero coefficient should have non-zero coefficient. So this is coefficient minus 4. So should have non-zero coefficient. And variables having non-negative exponent. This will be clear after the example ahead. It's called a polynomial. Okay. So we'll try to understand with this. The examples are 2x plus 3, a plus b plus c plus d, phi x or phi yz are polynomials, and 0x or y raised to minus 1 are not polynomials, as coefficient of x is 0, we should have non-zero coefficient, and exponent of y is minus 1, should be non-negative. This is called exponent, this is non-negative. So these and these two are not polynomials, and these are polynomials. Okay, so we'll move ahead. Definitions of like terms and unlike terms, very easy to understand. Let's consider these examples or these definitions. 2x, 5x minus 4x, or number 2 is 5z square or minus 6z square, or 2xy axy. So can vary in constant but not in the variable or its powers. All are same. These are called like terms. Okay. So this xy, this is xy. These are like terms. And unlike terms, like if anything is different, any variable is extra or when power is different, then these are unlike terms. Consider the examples: 3xy and 7x are unlike terms. Then 6 minus 6z square and x square are unlike terms. Only phi and y, these are all unlike terms. Okay. Variables and their powers decide the terms are like or not. Variables, which variable it contains, and their powers decide whether terms are like or not. These are very useful in solving examples. Try to understand these, and we will see how this is very useful in the problem solving process. Okay. The last one in this definition topic, the addition subtraction rules. These are rules, these are not definitions. So first one is write the like term one below other. You will understand it when you consider some example. And if there is no like term in the polynomial, then leave the space empty or vacant as shown. This will be clear from this example. We have example 1, 7x square plus 3x plus 4y plus 3, some arbitrary example. And another example is 2x plus y plus 10. Then while solving, either adding or subtracting, okay, you write these all in this order. Then whatever may be this order, you have to write like term below like term. Okay, so this 10 constant will come below constant, this y will come below y, x should be below x, and as this does not have square term, so this will be vacant, okay, or empty. So it is given here as example 2 does not have x square term, then we keep space below x square empty. Okay. So after learning this, let us try some problems, discuss some problems on this topic. Okay, and try to understand the topic in a better manner. Okay, so we try to solve some problems on the topic. We are here trying to add the polynomials, add the following polynomials. And what are the polynomials? They are here. First one is AB minus BC. Second one is BC minus CA. And third one is CA minus AB. Okay. Answer: check for the different terms involved in these all these polynomials. Okay, what do you mean by different terms? AB is one term, BC is different term. Okay, if you see another BC in any other term, that is the same term. Okay, you just check for the number of different terms and keep a different columns for separate terms and write one term below another. This is very important. Okay, you will just check how this has been done. Okay, so this is AB, and AB, the green one, this is the first term. Then second term is BC and BC, second term there are two, and CA and CA is third. So there are three terms, three different terms. So you will need three columns. Actually, you need not have actual columns. You need not even number the columns. I have done it just to understand. Okay, there are three different terms, therefore three different columns. You need not write all the column numbers. Okay, in actual exam, but follow this. See, I am adding it, AB minus BC. This is the first column, but don't write it in actual problem solving. This is just to understand. 1 2 3. Okay, now write AB below AB, BC below BC, like that. Okay, plus now it is BC below BC and CA CA, third. Now third one is plus CA, the right below CA, and minus AB, right AB, like that. Okay, that should be done. Now add. So CA CA cancels, plus minus, BC BC plus minus cancels, AB AB also plus minus cancels, and you are left with only 0. So answer is 0. Okay, remember. So second exercise or second problem, add these polynomials. Okay, see, there are different polynomials. What are these? L square plus m square, m square plus n square, n square plus l square, and 2lm plus 2mn plus 2nl. Last one, all three digits is one polynomial. Answer. First thing is you have to find the number of terms or different terms that are present in these all these polynomials. See, these are different terms, you mean. Okay, we will just count them. This is 1, this is 2, m square already here, this is 3, n square we have counted, this is also counted. So this is 4th, 5th and 6th. So there are 6 different terms, and so we will have 6 different columns. We will not name or actual draw the columns, but we will just follow in 6 terms and 6 column, like that. Okay, see how it is done. Okay, in exam also you have to, or in actual solving you have to do the same thing. See, L square plus m square. Now when you add another one, write m square below m square and n square besides that. Now while adding the third one, write n square here and L square below L square. Okay, and the fourth one, there is no repetition there, so 2lm plus 2mn plus 2nl. You got it? So 6 terms like this, so that it becomes very easy to add a term below term, L square below L square. If there is one L, that will be different term. Okay, so see how it is very easy to add this. 2L square plus 2m square plus 2n square plus all this. Okay, so in this you can take 2 common. So answer will be take 2 common, and in bracket you will get L square plus M square plus N square plus Lm plus Mn plus NL. That's all. That's the answer. See how simple it is. It is very easy. Okay, that is the answer. So after adding the polynomials, different polynomials, we are now trying to go the another aspect of polynomial, that is subtraction. How to subtract one polynomial from the another polynomial. Similar to the addition, we have to write similar term below similar term. Okay, so we will directly read the polynomials 4a minus 7ab plus 3b plus 12, and we have to subtract this polynomial from 12a minus 9ab plus 5b minus 3. Okay, now we will check for the different terms. So a, all the terms which only a contains, or ab, or a square, or b, or b square, all this will be different terms, or constant that doesn't have any a or b, like that. Okay, so check for the number of terms. Okay, each will be different term, and see how many total different terms are there, so that so many columns you will need. You will not make any column, but try to follow one below other. That is what is written there. We have to write a similar term below one another. Okay, that means what? We will just see. We will write that polynomial from which we have to subtract. So we will write that first. These are the terms. A will be, AB will be another, B will be one, and a constant will be one. There are four terms. Okay, remember, actually how many terms, this is very simple problem. How many terms are there? Sometimes it may contain different term. Okay, that we will come across it. So we will solve this. 12a minus 9ab plus 5b minus 3. Okay, then while writing the another polynomial a below a, that is 4a, then minus 7ab, then 3b plus 3b, and constant below constant. Even if that is not given in this order, we have to make the order according to the first one. Okay, now as we have to subtract, we change the sign. Change the sign of the second polynomial. Okay, this will be plus, this will be minus, this will be plus, this will be minus, and minus. Now it is very simple. Now subtract from the right hand side. Minus 3 minus 2 is minus 15. 5 minus 3 is plus 2b. Minus 9 plus 7 is minus 2ab, and 12 minus 4 is 8. 8a. Okay. So we are solving the problems of subtraction, subtracting one polynomial from the another. You know, the basic method remains same. You have to check for the terms and write the same terms one below other. Okay, that rule follows here also. So we read this problem: 4p square q minus 3pq plus 5pq square. So all three different terms, minus 8p plus 7q minus 10. You have to subtract this from another polynomial. See, is given constant 18 first. So these terms are not given in order. Okay, you need to make them in order. We will see what to do. We'll read it. 18 minus 3p minus 11q plus 5pq minus 2pq square. Okay, plus 5p square q. Whatever it may be. Answer. As you know, we have to write the terms in a proper order. Okay, either you write it in some order, or you can take as it is. I am not presently, I am not arranging them in any order, because there is no such a rule, no such hard and fast rule. So I am just copying the polynomial from which you have to subtract another one. So I am just copying it. Okay, you can even rearrange, or you need not rearrange. Okay, I'm just copying it as it is. Just see, 18 minus 3p minus 11q plus, don't make mistake in copying, then that will be a blunder. Okay, so that is the same thing. Now when you subtract it, you have to write the similar terms below the similar term. See what should be first 2, then this is third term as you can see here, then this is fourth term, then this is fifth term, and this you have to write in this order because first constant is given, so you have to write it minus 10 along with sign. Okay, now second is minus 8p, don't make mistake in sign, plus 7q minus not minus 3pq minus not minus plus 5pq square and 4p square q. Okay, now you have to change the sign. As you have to subtract, you have to all signs will change. Okay, so I have to change, plus will become minus and minus will become plus, and then starting from the right hand side, minus 4 plus minus is only p square q, so it is now very easy arithmetic calculations. Minus 2 minus 5 is minus 7 pq square. Now this will be 8 pq, yes it will be 8 pq. This will be minus minus 18q minus 18q minus 18q. Sign is very important. Okay, minus no, the 8 is plus, so this will be plus 5p, and this is plus 28. Okay, now you can arrange or even keep as it is. There is no harm in keeping, but let us arrange. It looks nice. Okay, so I just arrange this way. I am taking p square q minus 7p q square, all first p square, then q square, then the pq, that is then p, then q, then constant. Okay, that's it. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic, let me know through comment section and I shall solve it. Thanking you. Good luck.